Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at catalyzing change in high school mathematics. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight, I'm excited to be joined by our two panelists, Gail Burrell and Jeremy Zelkowski. Gail was a secondary teacher and department chair in suburban Milwaukee, Wisconsin for over 28 years. She is currently a math specialist in the program for math education at Michigan State University. She served as president of the National Council of Teachers of Mathematics and as director of the Mathematical Science Education Board. Her research interests are statistics education, the use of technology in teaching secondary mathematics, and issues related to what it means to teach mathematics. Gail, thanks so much for joining us.
Glad to be here, Jeremy.
And Jeremy has taught high school and college math all the way from 1999 up to 2008 and joined the University of Alabama in 2008 as he completed his doctorate in mathematics education. He is currently an associate professor and the program coordinator for the secondary math teacher education at the University of Alabama in Tuscaloosa. He's been a T-Cube national instructor since 2014, offering workshops and doing conference presentations on TI-Nspire throughout Alabama. Jeremy, it's great to have you with us tonight.
Good evening, Gail and Mike.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions you have for Gail or Jeremy using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, this session is being recorded, and we'll provide a link for the event certificate of attendance as well as a link for the documents at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the very top of the WebEx menu and choose Audio Broadcast. At this point, Jeremy is going to share some information, including our agenda and some expected outcomes for tonight. So, Jeremy, feel free to share your screen.
Okay, thank you, Mike. Okay, so tonight's agenda, we were going to do those brief welcome and introductions that we just saw. We're going to introduce catalyzing change. And we have three activities tonight where we're going to talk about some things from catalyzing change. We've just been very selective with some very specific things from catalyzing change, addressing a common algebraic problem, connecting linear and exponential functions, investigating mathematical patterns, as well as addressing the recommendations in catalyzing change. And we're going to present a couple of things that come from that, and also talk about some free online resources. Additionally, we have some expected outcomes that we hope to have you all leave this with. So become familiar with the NCTM document Catalyzing Change. Explore activities, why does that keep doing that? Explore activities highlighting the essential concepts in catalyzing change. Consider how dynamic interactive technology can support the development of those concepts, and stay in touch with social media and some upcoming events. At the end of this webinar, we will be giving away a free registration to the T-Cube International Conference in Dallas, March 2020. So for those of you who stay on till the end, stay around for that. So we're going to start with a hearing from our participants tonight. So we'd like to know what our audience sort of knows about catalyzing change. So in the chat, so not the question and answers, but the chat feature, how many of you here tonight have read parts or all of Catalyzing Change or are familiar with this publication? We'll give you a couple minutes to respond.
And as you're doing that, in case the chat window isn't open for you on the right side of your screen, another way to open the chat window is if you move your mouse on your screen, you'll find some buttons that appear at the bottom of your screen, and one of them looks like a chat bubble. That will, if you click on it, that does like a hide show for your chat window. And as you're responding, the default for the send to, I'm hoping it's going to be all participants. That's what we want to do. Send your chats to all participants. Thanks so much.
Looks like we have a mix here, Jeremy.
So that would
have read the whole thing. Some people have purchased it but haven't read it yet. And some people are not even familiar with it, but are really interested and eager to learn. So we have run the gamut. So let me just start a little bit by saying that the Common Core state standards and whatever derivative your state is using actually probably address things were needed to be taken care of in the elementary and the middle school fairly well. But the Common Core did not really tell us very much about what's going on in high school mathematics and how we can actually improve what we're doing. And NCTM recognized this as well as the kind of lay of the landscape, which a lot of our problems in education and mathematics come to fruition in the high school, where many students aren't being given the opportunities or the access to the kind of mathematics that they need. And so this document is written intending to address those issues, not providing answers, but providing opportunities for people to talk about some of the issues. And it really is catalyzing change, initiating critical conversations is what it's supposed to be about. And so basically, the thing we're going to talk about tonight is the common essential concepts pathway and essential concepts. So next slide, Jeremy.
Okay.
And so one of the really interesting things about catalyzing change is it has re-centered our focus in mathematics and teaching mathematics. So for the last 10 years, can't even remember how long, we have been college and career ready has been the way we've been thinking about what's important in mathematics. This document reminds us that there's more to mathematics than preparing for what comes next, that it should help us understand and critique the world and experience the joy, wonder, and beauty of mathematics. So it's reminding us that's the roots of mathematics didn't come from expanding professional opportunities. They came from people needing to understand the world and people who were intrigued by the mathematical things that they saw and tried to figure them out. Next slide, Jeremy. And so this document is not a curriculum document. Instead, it says, building on the middle school, let's define some foundational mathematical ideas that all students, no matter where they come from or what their background, should take for whatever future path they pursue. And the domains are pretty much the same that you would expect: number, algebra functions, geometry and measurement, statistics, and probability. Next one, Jeremy. One of the big emphases in catalyzing change, at least from my perspective, is that there's a big shift in the role of technology. So technology is looked on as something to help students gain access, to provide opportunities for students to interact with the mathematics without being hampered by doing some of the complicated calculations and computations. And so the emphasis is on using the technology to develop understanding and to investigate and to think deeply about some things in mathematics. I know many of us have already been doing that, especially those of us in T-Cubed, but it's not necessarily a clear-cut way to approach ideas. Many people are still thinking that kids need to learn to master everything by hand before they can touch the technology. This is actually going directly the opposite. It's saying, give students the opportunity to learn about mathematics using the technology, not letting the technology be the cherry on the cake after they have learned it. Next one, please.
So I wanted to add real quick, Gail, one of the quotes that I like from this book is, we have pockets of excellence, and those pockets of excellence is what we're hoping to build from.
That's a great, because it's not like everything is wrong. There are many, many good things that are happening in the high school arena. And so we need to recognize and build from those. That's great, Jeremy, thanks. So here's a question that we're going to look to. Does the a plus b to the nth equal a to the nth plus b to the nth have a solution? So this intrigued me because at Michigan State, they say that squaring a sum into x squared plus 9 is the freshman dream. And they've asked me why their students in college don't know better. And I'm like, well, we've tried to tell them. And then this problem, some of you who teach AP Calculus might recognize this from the potato problem. Students just did terribly in advanced placement calculus on this problem because they distributed in the exponent over the subtraction sign. So I'm thinking that there's got to be a way that we can use to help our students get underneath this kind of classical wrong way of thinking. So Jeremy will share his screen.
Move to the TI-Nspire Teacher's Edition software, and Gail's going to do a little demonstration here for us.
And I'm hoping everybody is looking at my screen right now.
Yes, we're seeing that.
All right. So what I've done here is I'm using an Nspire. I've just gone in and set the slider. I mean, when I teach this kids, I teach elementary pre-service students, and I often ask them this question and let them just explore. And so some kids might do something like this. They might take a slider and look at what's happening and see, well, when is it ever going to be equal? When are these things going to be equal? What's happening as I change the power? I can change the base. So if I want to, I could make this one 5, and this one 5, and I can see if anything different happens. So I can make the technology actually work for me and tell me what's going on. Another thing that the kids might do, and this one's kind of fun, actually, it's kind of the same, but the slider is set up in fractions, so it goes by increments of a half. And this one is kind of interesting because it is an essential concept, not that students need to be able to simplify radicals, but they should be able to interpret it. So why did 3 to the 2.5 come out to be 9 times the square root of 3? So if we really think about what that means, 3 to the 2.5 means 3 to 2.5 factors. So it means 2 factors of 3, which is 9, and another half factor of 3, which is the square root of 3. So the same thing with why is 5 to the n 25 to the square root of 5? It's because we have 2 factors of 5 and a half a factor of 5. So giving kids the opportunities to investigate, think about, and talk about those things is a key part of helping them confront the fact that 3 plus 2 to the nth is not the same as 3 to the nth plus 2 to the nth. One of my contentions is that we go way too fast without letting them play with it. Here's just another example of both of sliders where you can look at it a different way. And you might even be able to have some kids graph it. So let's look at the graphs and let's just set the sliders up and see what happens as we change the sliders. So Jeremy, you wanted to say a few things.
Yeah, so as Gail's moving the values of A around here, we kind of see graphically that regardless, at least as long as A and B are positive, we're seeing a point of intersection between these two functions. And then if we make one of them, A or B, 0 in this case, we'll actually see something kind of hanky going on. This may have students wondering about some things. Why did something change when B is 0 here? And we actually don't see the blue F1 function. And then even if you make one of those values negative, we see even some crazier things going on here graphically. And so there's a lot of things that students can wonder just by changing these A and B values. And if we go back to where B is positive here, we actually see that we do have a solution that's happening here, but it's different depending on what A and B are as far as where that point of intersection is. So it at least gives students an idea that there is a value that does make these things equal for particular A's and B's. And then there's some weird things going on with A and B when they're negative or 0.
Thanks, Jeremy. And it's also possible to graph the fractional power. So kids need to recognize what that might look like. And it's not clear to me that we spend enough time helping them look at that. So notice here that the red graph is always above the blue. So what's mathematically going on? What would make that happen? We could put the trace on and look by how much it differs. It's clear that the difference is small here and it's getting larger. So there's a lot of things that kids can talk about that actually all reinforce that idea that the sum of the squares is not the same thing as the square of the sum, which maybe would go a long way to helping them overcome some of the problems they have with the manipulation when they get going outside of the initial algebra realm. So, Jeremy, I'm going to turn this back to you.
Okay.
I think. Assign. I'm making Jeremy the presenter.
Yeah, let me make the... Okay, so...
If anybody has any questions, please put them in the chat. I kind of rattled on about all this. So I'm sorry if I didn't pay any attention to anybody's questions, but...
Yeah, I was kind of watching the slides too, so I'm going to kind of peek. There's only a couple of comments. Time is precious. In the testing world, we don't always have the amount of time that we need. And I think Gail and I have similar contentions on this, that sometimes, and we're going to kind of, this might actually help us here in a little bit, is we generally can create some time if we look at the computational aspects that the technology can sort of erase the problems where students get frustrated and stuck just on computational mistakes, rather than having enough time for the opportunities to kind of explore some of these things. So that's one of the things that Catalyzing Change, it's not the focus of our webinar here tonight, but it is part of the Catalyzing Change document on where we can sort of remove some of those computational barriers with technology. Gail, you were going to do the slide?
Yeah, so just type in the chat, what do you notice about the graph or the table? What do you wonder? We're letting you have time to type. Anybody notice anything? Anything you would want your kids to think about?
And keeping that in mind, that we're still looking at that binomial term squared versus the squaring of the monomial terms. Similar shape, symmetrical. Anything anybody notices in the table? From the parent function, one is a shift up and the other one is a shift left. Okay. Notice that they have the same value at 0. So that's a connection between the table and the graph. One looks like a translation of the other. So we're seeing some of the translations or transformations here. The red graph seems to be a translation of the blue graph and vice versa.
I really like the way everybody is thinking about the graphs, but it would be interesting if people notice something about the values in the table as well, and how those values in the table relate to the graphs. Well, like that blue gets wider faster. We could investigate why that happens. And then we could see if it's true. Anybody notice anything? Perfect squares?
So I see a comment here, starting in the table with the values, the blue function starts increasing with perfect squares. So we notice the perfect squares for the blue function. The red function, we see a difference of 7, then 5, then 3. So there's somebody making it, recognizing that pattern.
So I think these are so great, because what you really want the students to do is to have a conversation. So why does the red graph have no 0 value? Why does that, what's going on there? Why is it never 0? How can we see that in the table? Why can we see that in the expression that describes the graph? How can we tell that it's not ever going to go through zero? Some people noticed that the red values for a given x, on the right side, the red values are less than the blue values. On the left side of zero, the red values are more than. Why is that? What's going on there? And so we're noticing all sorts of patterns, and I think that's really important, and technology can let us see those patterns. And eventually, some of your students might actually even notice that the difference in the numerical outputs is that middle term 4x. That in the negative sign, that 4x is being taken away. In the positive x values, the 4x is being added into the values. So giving kids the opportunities to have a conversation about how these, what they're seeing and how these things are connected is absolutely critical. You guys made some really good observations. Thanks. Jeremy, over to you.
Okay. So we have a little chat here that we're going to we want to get a poll sort of what you think. So we're asking the question, what content in Algebra 1, or if you have an integrated curriculum, the first year math course, what is important to you? What content is important to you in that course? And we're going to give you about 2 to 3 minutes here to respond to this so we can get a pretty decent sample. I'm not going to read all these. I'm just going to kind of watch them, and everyone else can kind of watch the There's a lot coming in. Very, very common types of responses that we would expect to see. This is essentially what we teach in Algebra 1.
I'm amazed at all the people that I think factoring is important.
So yeah, so we see a lot of things in here, and this is kind of where we've done some. I've done some survey work already to kind of collect broad categories. So mostly inequalities, equations, factoring, which would be with quadratics, graphing functions, linear functions. So I'm going to kind of advance here to the slide. So those are kind of the things, and some very narrow ones and good ones in here, like modeling, trying to do more modeling, intro to functions, quadratics, exponentials. So you all sort of saw the responses, and this was a survey that is part of work that I'm doing right now. And we had 234 responses from Algebra 1 teachers, and we just asked them specifically about functions. And as you would expect, just from our chat, most of the responses have historically been with linear and quadratic. And in our survey, we had just barely over 10% of the responses that mentioned exponentials, and that's kind of reflective of what we saw in the text chat. And so what we're going to kind of move into here is this idea of what catalyzing change does to, for us to try to start thinking about the impact in the high school curriculum. And so this is just very specific to Algebra 1 or your first year math course. And so some master teachers that have been working with me in a project that started this summer and has continued in this fall, they read parts of Catalyzing Change. They sort of examined their own practice, and they produced this summary as their new approach to this academic year. And so in this case, they had a lot of professional development support this summer to be able to be ready for this academic year, which is not the case, but that's generally what we get for support in education, obviously. But they saw value of building from linear to start the year, which continues from the 8th grade course of study, where we do lots of things with linear expressions and equations, but then plan to sequence exponential in much greater detail than their previous years within their curricular plans, because they saw an opportunity after reading the Catalyzing Change and doing some activities with us this summer, that they really started to see greater connections between how exponential is so much similar to linear functions than maybe quadratics are. And so in Catalyzing Change, there's a really nice paragraph that's based on a quote from Zhao Ziskin in 1995, but is in the NCTM Catalyzing Change book on page 45. And I'm going to just kind of let you read that quote. But the teachers we were working with this summer really started to look at this in terms of rate of change being the focus between both exponential and linear functions, where we don't necessarily have a point and a rate of change, sort of the language that we use with exponentials. And so they purposely use this term point rate of change rather than, say, our point slope form, to start thinking about both of those functions in terms of a rate. And this is one of the things Catalyzing Change does to us, is thinking about how to make connections more explicit for students, particularly with respect to algebra and to the functions that we study. And so by drawing connections from linear to exponential, we see that the behavior of quadratics is much different than linear and exponential, which are exclusively, linear and exponential are exclusively increasing or decreasing or monotone, with the exception of our constant function that would be horizontal or constant. But that's not the case with quadratic. And so linear and exponential functions have many more real-world applications to contextualize the study of these functions than would quadratics. And so we typically see some of the textbooks, categorized quadratics, projectile motion and such. And so we have more of a balance of time. Catalyzing Change is not telling us to reduce or not teach about quadratics, but it's about balancing the time of study more so with functions that are more real-world applications based, like exponential, instead of having that, like what we saw here tonight, and then also from that survey that I did these past couple of years, that we actually see that exponential takes a very, very far back seat to linear and quadratic. And that's what Catalyzing Change is trying to get us to think about, is how do we have a much greater experience for students at the high school level. And so this slide is essentially just a different way. This is the graphical representations where we can think about linear, exponential, then even quadratic, the three predominant functions that we see in Algebra 1. Gail, you want to add something to this?
So I'm pretty sure that I never did this as an algebra teacher, and I should have. So if we look at the linear one in the upper left, we're going over 1 up 2, over 1 up 2, so the rate of change is constant, over 1 up 2, over 1 up 2, and it's pretty clear, and I did a lot of that in Algebra 1. What I didn't do was actually look at the rate of change that would happen in an exponential, which is the one in the lower left, over 1 up 1, and then it's over 1 up 2, and over 1 up 4. So the rate of change is very different. And the quadratic is over 1 up 1, over 1 up 3, over 1 up 5. So getting kids to look at that and talk about which one is growing faster and which one will continue to grow faster is really important for them to think about. And some of you mentioned modeling, the idea that when you model something, sometimes it looks like it could be an exponential or it could be a quadratic. You need to think about the consequences of going with either of the models. So I think there's a lot of questions that you could ask kids to think about here, both with this slide and the last slide, and I think they would pay off in their understanding of these three important functions. And these are the three functions that Catalyzing Change says are the key functions that every kid should understand. Well, we know that the trig functions and logarithmic functions and absolute value functions are all interesting and important, especially for those who are intentional in some kind of a STEM or more of a mathematical focus. But for every kid, the people that wrote Catalyzing Change really thought that the core three functions were these three: linear, quadratic, and exponential. And they should start with the algebraic approach in algebra. And then when basically Catalyzing Change says about 2.5 years for geometry, statistics, and algebra. And so in the second year, when you move to thinking about functions, then these are the functional ideas that you should have, and you should start using words like increasing and decreasing. So Jeremy used that before, but those are words that go with algebra and with functions. And when you describe the relationships that you see, kids should be able to take those words and match them to visual images of the graphs. So I'm not sure if anybody has any questions about that. Oh, I do want to say, factoring, it doesn't mean that I don't think factoring is important. I think factoring is really important, especially if you relate factoring a quadratic to how it comes out of its linear components. I think that's really key. But I also really think we should be relying a lot on the technology to do the factoring for us, and let kids actually think about what does that mean? How do the factors relate to the graph? How do they relate to the zeros? And what's going on in terms of the concepts that are involved in factoring, not just the skill of factoring.
Yeah, so there's some very good comments. Yeah, there's a couple good comments, and so one of those is understanding the slope as rate of change, especially thinking about it and how that's going to help students when they do reach calculus, is understanding that idea, since that's the story of Calculus 1. Okay, so next slide here, we have sort of a, to yourself, what do you observe? So choose a couple of whole numbers, A and B, not too large, just for computational reasons. And I'm going to switch the screen over to Gail, and she's going to start sharing something, but we're going to let you kind of start doing some computations of taking the squares of your choices of A and B and the difference of those squares, the addition of those squares, and then 2 times the product of those values. And we're going to look at a technology component here with Gail.
Okay, so I should be ready to share my screen.
Yep.
And are you guys seeing my screen?
It's loading. There we go.
All right. So I'm going to need you to type your answers for these 3 computations in the chat. So if you can share in the chat the numbers that you're getting, that would be great. Trying to figure out how I can look at the chat. I can't look at the chat at the same time.
Yeah, so I'm watching it. So we've got.
You have to tell me what's in the chat.
Yeah, so we've got some folks that are. So we have 5, 12, and 13. 41, 9, and 40. We have some folks that are 3, 4, and 5. 17, 15, and 8. I saw 34, 16, and 30.
Okay, so now you guys have looked at those numbers. What are the conjectures that you might make?
And I have somebody who has typed Pythagorean triples with a question mark.
And what do we think? Do the rest of you agree that these are Pythagorean triples?
So we got a second. It says it's Pythagorean triples. Way too cool.
Okay. So if we go along with those as Pythagorean triples, I want to look at just a special subset of Pythagorean triples. So I'm going to go to this next page. Come on. Okay. And they're called primitive Pythagorean triples. And I'm going to generate some using this TI-Nspire file. It's actually on the internet, on the TI website. It's called, I think it's Pythagorean Theorem Exploration under Algebra 2 Insights, Algebra 2 something or other, Inspire activities or something. So I've got 3 here. I'm going to put a 2 here. I'm going to put a 4 here and a 3. And I'm just picking these numbers. Notice that the numbers I'm picking are consecutive, and I've got my screen in the computer mode so that I can show you more of them. I
Yeah, that's a
could do
good
a fill
point.
down, I suppose, but I'm just gonna drop these off here.
So that's a good
And
point.
you should be noticing any patterns or anything that you see. These are being generated.
So Gail, let me chime in real quick. So that's an important point for those that may be using the TI-Nspire for demonstrative purposes in the classroom, is you're using the computer screen version rather than the handheld version, so it gives you more screen space if you want to have students see more when you're demonstrating in the classroom. That's not that common from what I've learned so far.
Yeah, so if I go to handheld view, it scrunches it.
Yeah, that's
So
typical.
Computer view, now you can see more of what we went.
That's true for the graphing pages as well.
And so how am I generating these? Notice down here, it's a squared minus b squared. Okay, and this is the a and that's the b. This one is the 2a and b. This one is the a squared plus b squared. So now what I want you to do is to concentrate on these three columns and tell me what you notice, what you wonder. Type it in the chat. What do you notice? What do you wonder? What's going on here?
Oh shit, there's a question. Why did it skip 8, 15, and 17?
I don't know.
Oh, you know, Gail, come on.
Why do we think it skipped 8, 15, and 17?
Maybe it has something to do with what we're supposed to be seeing.
I think so. Somebody pointed out that column C is the sum of the first two numbers. Julie's answering, she says 8's not odd. Ah. I think it was Caitlin. So I don't know about you guys, but I never knew that every single odd number was a member of a Pythagorean triple. I never knew that.
I didn't until I looked at this myself.
That was like totally blew my mind. That every single odd number that you can think of, because if I continue to generate this pattern, I'm going to generate the odd numbers. So that's a pretty awesome thing, I think. Any other patterns that you noticed? That I saw some. Anything else coming out? There's a probably theorem there. Well, there could be.
That's good. There's probably a theorem from number theory that says this, whatever we're going to say. That's a really good one.
So
I would
notice any connection between the hypotenuse and the longest leg?
So that was somebody, Molly said the last column is 1 greater than the fourth column. She had said that a minute or two ago.
Oh, okay, great. I didn't see that.
I
So
missed
that's
it.
a good connection. Anything else you notice? I really want you to notice something about column D. This might be kind of hard for you to notice.
Yeah, anything about the twice the product.
It's up by multiples of 4. Yeah. Multiples of 4.
All multiples of 4.
I label this column mid, and I go over here. Oh, shoot. Cannot accept change. I wanted to do something. I just wanted to give it a name. Why can't I give it a name? Okay, so I can't. All right, anything else you guys notice? Appears to be half. All right, so I want somebody to tell me I'm going to go over here, and this middle column is 4 times 1. Then it's what? 4 times 3. Then it's 4 times 6.
6.
Then it's 4 times 10. Then it's 4 times 15. What do you notice? What do you wonder? Anybody want to conjecture what the next one will be? All right. Julie says triangular numbers. And it goes +2, +3, +4, +5. Awesome. So the middle column is 4 times the triangular numbers. So what do you guys remember about the triangular numbers? Let's think about this in the chat. Anybody remember anything interesting about the triangular numbers? Ooh, Julie tells me that they're n times n plus 1 over 2. That's awesome remembering.
And so even Mariah says I was looking at the difference between consecutive numbers, so there's something there too.
Bowling pins. Michael's thinking of the handshake problem, right? So if you think about the number of handshakes, if there are 2 people, there's 1 handshake. That would be this. If there are 3 people, there are 3 handshakes. If there are 4 people, there are 6 handshakes. 5 people, there are 10. And it ends up with n times n plus 1 all over 2. This is a really cool way to introduce students to quadratics as opposed to linear, because the differences here are 2, 3, 4, 5. So the differences the first differences aren't constant like linear. The second differences are constant. And so that's what tells us that it's a quadratic. That
So that was one of the things that I see Shelby typed in here, +2, +3, +4, +5. So that gives you the opportunity to look at that, the differences, to make some connections to what Julie had put in there, that why it's modeled by a quadratic, that n times n plus 1 over 2.
Right, and it's oh, you guys are awesome. Somebody noticed that this is also connected to the Pascal's triangle at the binomial theorem. These things are great connections. And so part of this, the reason why I like this is it's embedded in the beauty and wonder of mathematics. So you're helping your kids understand something about mathematics that's really important and awesome. And looking for patterns is a really a critical skill that should be coming out of what we do with our students. So we're not just preparing them to do a procedure to solve 5 different kinds of equations on the assessment. That's important, but we also have to take time to let them understand that this awesome stuff goes on with mathematics, and let them play with it and make conjectures and check them out. And technology is a great way to let that happen. So I really would encourage you all to find ways to let your students experience this. The triangular numbers are just a fascinating place to see. The fact that the right triangles are connected to the triangular numbers is a really interesting, I think, and a fascinating thing for kids to think about. So I'm going to stop sharing my screen again, turn this back to Jeremy. And see if anybody has any questions or thoughts. I just heard a great session where someone introduced the whole notion of quadratics out of the handshake problem. It was a really cool presentation of how you get kids. It was at an NCTM regional in Salt Lake. No, it was in Nashville. How you get kids to understand that.
So
Okay,
there's a
so
question.
we spent some time thinking
There's a
about.
question in here, Gail, on, so I'm going to go back a little bit. So there's a question about which class do you see this activity taking place in and at what point of the year?
I would ask you guys in the chat, what class would you see this activity taking place in? I see Algebra 1, Math 1. Free algebra during the Pythagorean theorem, that seems like a logical place to go. Geometry. I can tell you that I used to do it all the time in Algebra 1.
So I did it in
get my kids,
Algebra
that's when
1
we did the handshake problem.
Yeah, so I did it in geometry because I used to teach the finite differences modeling in the geometry course, since there's so many ways to do modeling of polygons and sides and diagonals. That's where I used to do it, but I can see it easily fitting into Algebra 1 when you're trying to introduce quadratics or building from what was done in the middle school. So it could start the year just where you're looking at the patterns, but you're not necessarily doing the algebraic modeling. And so there was another question about how do you present this to schools without technology. So that is always a caveat. That's always something that is an issue in schools that are not well funded for that. I would say, though, from the perspective of what Gail just did, where we kind of show and demonstrate and ask questions. So I think that's a way, if even if kids don't have the technology in your hand, that we can still leverage technology to ask those kinds of questions, where they can see those things, like those tables that Gail was creating. So that is an important piece, is even if it's just for demonstrative purposes and the students don't have it, we can still use the power of technology for those kinds of things to happen. Not the way that we would ideally like it, but.
And I did this one on the Nspire, but I didn't have Nspire back in the day. I had 84s.
Neither did I.
So it took a little imagination to maybe make it work so easily on the 84s, but you can do it. So you don't have to have an Nspire to do that problem. Okay, let me turn to so we just touched a little bit of geometry. We touched some algebra. A big part of catalyzing change is quantitative literacy and statistics. So that one is a huge emphasis, and it's the first document that's ever put quantitative literacy into the place in the curriculum, where quantitative literacy means making grown-up sense out of numbers and things, data in the world. So being able to think about the opioid crisis. We didn't put all these slides in there, but there's a lot of real-world context that kids need to make sense out of, and Catalyzing Change says that that's really an important part of what we should be doing in our curriculum. And they also have a lot to do with statistics, just some of the statistics that you would remember and think about building off of the middle school. One of the big things that they emphasize in the high school is not only the box plots and the data analysis things that you might be used to, but they also emphasize using the technology to help students answer questions like this one about Steph Curry, and answer probability questions, look to see if outcomes that you observe are due to chance, by generating, this comes from Building Concepts, Statistics, and Probability. It's a Prob and Sim app, where it's got a spinner, a coin, and a die. Actually, it was designed by Becky Meyer, who I think is one of the people that's with us tonight, I hope. And she did a great job. So you can use this little app, and you can answer all sorts of questions about, well, would you say that something that happens less than 5 out of 500 times is by chance, or is there really something going on? And so this gives kids an opportunity to investigate kind of real world problems involving statistics, and that's a big focus, as well as pushing that a little bit to inference and being able to talk about things like margin of error. And so I think it would be really useful for you as you're thinking about redesigning your curriculum that would to allow some statistics in here, to look at what Catalyzing Change suggests that we would take time to do. Any comments or questions about that?
Yeah, so I'm gonna, when we close, we go into our closing here, there's a couple of comments that I'm gonna make about the statistics part being integrated into our high school courses.
Okay, on to the next. All right, so I taught history of math last year at the university, and I came across this slide, this quote, and it struck me that we've a little bit forgotten what Leibniz was about. He's like, it's unworthy of excellent men to lose hours like slaves in the labor of calculation, which could safely be relegated to anyone else if machines were used. So he spent a large part of his time trying to find some way to do automatic calculations so that he could think about the relationships among the numbers and the ideas. And that's what Catalyzing Change is trying to get us to think about in terms of technology, that this technology can put kids in a different playing field if we let them take advantage of it. So that's kind of the message about technology from Catalyzing Change. Over to you, Jeremy.
So to close tonight, we're going to share a couple of things that as schools, whether in your school or whether across your entire district or LEA, that if you begin to start thinking about how Catalyzing Change may have you refocus or do something different about the ideas of high school mathematics, the important part of this I would suggest is there's 4 case studies that have some extensive results and some very good things to think about that may help you make changes or think about just what could we change, and whether that's large steps or small steps. These 4 case studies, you can find these on the Catalyzing Change website of NCTM, and so you don't have, those things, if you just Google that, you'll find those case studies. And each of them did very different things. And so I'm not going to go directly into those, but all of them have some very different things that have shaped what went on in these schools or districts. And they happened before Catalyzing Change. Catalyzing Change sort of used what research we've known about to be able to put this idea of let's talk about and create some critical conversations about what we're currently doing and what we might be able to do better. So I would recommend taking a peek at that if you're going to try to do something at the school or at the district level. Additionally, and so one of the things that I've sort of been following since Catalyzing Change release is that 2 states right now currently, which both are very different politically, they're both very different in terms of, at least as far as NAEP test, if you think those measure something very valuable, they do present a very different set of ideas and cultural aspects, let's say, but yet both states have framed their courses of study for high school around the recommendations for Catalyzing Change. And so part of this is just luck of the draw that these states were up for revising their high school courses of study in the year after Catalyzing Change came out. So the committees were all put together already. And so what Oregon is doing is both states are focusing on the essential concepts that Catalyzing Change, but Oregon focuses on a 2+1 as an effort to detract students or the tracking of students of lower socioeconomic or putting them into dead-end pathways as soon as they enter high school. So that may be Algebra A and Algebra B or Algebra 1, Part 2, where you sort of put all of your lowest level achievers. And so they have a very different model that they're going to try to move away from that. And that's one of the things the San Francisco City School District did with some very positive results for some of their lowest achieving students across their 4 years of high school. Differently, in Alabama, they are going to focus on all students taking geometry as ninth graders. So even if you were an accelerated student in middle school and completed the equivalent of Algebra 1, you still would take geometry as a ninth grader. But students that are not accelerated are still going to be taking geometry as ninth graders alongside their advanced peers, and then they would take Algebra 1 and Algebra 2 back-to-back as 10th and 11th graders. And some of the literature supports that having those 2 years of algebra back-to-back may improve their ability mathematically in the algebra area that they tend to have struggled with. So there's some literature behind all of these, and this is one of the things that we see states doing two different things, but being influenced by catalyzing change. Anything you want to add to that, Gail, before I put our contact info up?
Yeah, so let me just add a couple things here. So the Catalyzing Change advocates for common pathways for all students. It says it makes a distinction between tracking and acceleration. There will always be some students who need to be accelerated. I mean, we just know that. You guys have, in your class, you have some students who clearly are mathematically motivated to excel. You know, I mean, I had a kid that once we put him in algebra, he knew algebra. We put him in geometry. He knew geometry. We moved him the next day. We moved him to algebra 2. He knew algebra 2. He ended up as a freshman in our pre-calculus course. You've all had kids like that. And so acceleration is not a bad thing. Tracking is detrimental to most kids. And so that's what the Catalyzing Change, the discussion in between about tracking and acceleration is a really good discussion in Catalyzing Change. But
Yeah,
the idea is that, I'm sorry, Jeremy.
I was going to add that it also talks about teacher tracking as well, how we put certain teachers with certain kinds of students and vice versa.
Right. And so this common pathway that is, they're recommending that in 2.5 years, that all students take 2.5 years of the same math. And that math would be algebra, geometry, statistics, and functions. And it spells out these essential concepts that kind of stop after a 2.5-year baseline. And Alabama went along with one of the pathways recommended was the first year in 9th grade would be geometry and statistics. And then you would move into the algebra and functions for the rest of the students, the 10th and the 11th grade. So
yeah,
I just wanted to throw that in because that's a really important thing. And one of the things that we were trying to do here is to help you position yourself to have a critical conversation with your colleagues about catalyzing change in your school and district. Now the end, Jeremy. Thanks.
Yeah, so both of those states are integrating statistics heavily into all of the courses at the high school level.
All right, and we've got to give Mike his 2 minutes.
Yep. So we thank you both. Mike, let me pass the controls to you.
Thanks so much, guys. As we wrap things up, if you have any last-minute questions for Gail or Jeremy, please try to get those asked. I know we don't have a lot of time, but they will try to get them answered. Earlier, we had mentioned that the T-Cubed International Conference is coming to Dallas this coming year in March, and it's a really great place to connect with fellow educators. You can learn more on our website, education.ti.com. And tonight we're going to be giving away to one lucky winner a T-Cubed International Conference registration. And tonight's lucky winner is Rodolfo Maldonado. So Rodolfo, congratulations. I hope to see you as well as everyone else at the T-Cubed International Conference. Rodolfo will be in touch over email in the next couple of days to give you a little more information. To receive a certificate of attendance, go ahead and click that link in the chat window. Also listed is a link for the documents that were used tonight by Jeremy and Gail. And if these links aren't working for any reason, hang tight. You'll automatically get a follow-up email in a couple of days. And in that follow-up email will be a link to the certificate, a link to the documents, and a link to the recording. And for watch this on demand, go ahead and copy that link into your favorite browser to receive your certificate. If you're in need of any post-webinar follow-up, feel free to give us a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. Thanks so much, Jeremy and Gail, for everything you shared tonight. You really gave us a lot to think about.
Thank you all.
Thanks.
And thanks, everyone, for joining us tonight. We hope to see you back online real soon. Have a great night.